So this is just y2 minus y1 over x2 minus x1, or in a more mathematically written way, it'd be like f of x2 minus f of x1 over x2 minus x1. But that's just the slope formula. That's just rise over run. I'm going to make some people mad by spelling rise incorrectly. I can't remember if the y's go on top or the bottom. Oh yeah, Mr. Davis spelled it weird. That's right, the y's go on top. Man, he's a genius. Is that what you're thinking? No, but people forget if the rise goes on top or bottom. We do it wrong. You can't believe how hard it is for people, like not AP people, but to understand like just the slope between two points. Okay, so let's just like make an example and say I have something like this, and I want to find the slope between x equals 3 and x equals 4. In a second, I'm going to like look online for, there's probably like a video that explains this better than I can right here. I didn't really plan on getting into this right now, so I didn't have it prepared, but I can find it quickly, I think. So the average rate of change would be if I drew a straight line. I don't need to say the word straight, it's just a line. All lines are straight. Between those 2 points, and I found the slope between those 2 points. Sheila, I liked it a lot better when you were not at that table. You did? Yeah. So I'll give you an option. You can shut your mouth or go back to that table. Okay. You going to shut your mouth? Are you sure you can accomplish that? Okay. Are you sure you can accomplish that? Okay. All right. So that's average rate of change. Like here's 2 points, find the average slope between them. But it doesn't necessarily mean it was going that slope the whole time. What calculus is I don't want the average rate of change. I want the instantaneous rate of change. So if I drew this point close, let's say I want to find the instantaneous rate of change at x equals 3. Like not between two numbers, but at x equals 3. That 1 point, what's the slope? The problem with that is how many points do you need to find the slope? 2. And I'm saying find it at 1. So the way they approached doing this was, okay, let's slide this point a little bit closer. Let's say we moved it to 3.3. And I drew this average, a line between those 2 points, a straight line between those 2 points. Is that slope there a better estimate of the slope right here than it was when I used 4? I just made it better, right? I'm moving that point closer. What if I slid that point even closer to like 3.1? Did I get better or worse? I got better because I'm like, my 2 points now are really close, right? So this is why limits are part of calculus. Yeah. Between those 2 points, you mean? I'm changing that goal, though. I'm saying I don't want to know the slope between 3 and 4. I want to know the slope at 3. Specifically at 3. Like, say this is velocity or something. I don't want to know, like, your average velocity over the course of an hour. I want to know at this exact moment, how fast are you going? Which is a hard question because usually you need 2 points to find the slope. Just what I'm saying, though, is we're going to make those 2 points so close together that they basically become the same point. So think about limits. This is why limits are part of calculus. We're going to allow the distance between those 2 points to approach, but never actually equal what? So the distance, we're going to have 2 points that are so freaking close together they might as well be the same point. So the distance between those, we're just going to slide that point back and back and back and back and back until the distance between them approaches but can never technically equal what number? 0. So those problems that we did, they're all like as the limit approaches as x approaches 0. You're finding as the distance between those 2 points gets so small that I can say the distance, the slope at that 1 point is is whatever. I'm sure there's something online that'll give you a video that kind of explains this better than my words can. Are you? This is a con video. You guys can just talk for a second if you want. I should have had this ready before. I didn't, so just chill for a second while I look. Okay, this is good. Alright, so in this here, our objective is to find the slope. Let's say that let's find the slope at x equals 0. So I want to know this particle, or this car, let's say it's a car, we're driving along an icy road. When we get to here, and right there, we hit a patch of ice. And then you lose control of your car, and it just continues to go in the same direction that it was traveling. And it no longer takes curves, because your tires don't have anything sticky on them anymore. Or you can think about it as like it's orbiting around the sun, and then the sun's gravitational pull just magically disappears, and it just like wanders off into space. So I want to find that exact slope of this right here. That's called the tangent line. So a not great tactic for doing that would be to take the slope between these 2 points. But the actual slope I'm looking for is a little bit like steeper down than that, right? So this is not bad, but I can make it better. So if I just, what would I do with this other point here to make this a better estimate? Move it closer. So if I start moving that point closer and closer back, like that's way better than it was, right? Still not quite perfect, but better. And if I make it, infinitely close, so the distance there is 0.05. Theoretically, the distance will be like 0.00000001. It'll approach 0, but never be 0. But we get a much better estimate of the slope of that specific spot, right? That's a tangent line. That's calculus. It's not actually what we're doing today, but I wanted to start talking about it. So today we're going to find the slope of, for example, that line and the equation of that line. And then tomorrow, and for the next 2 months, we'll start getting into, okay, what about at that one specific point? We no longer need 2 points to find the slope. We just need 1. And that's what calculus is. So instead of like an average change, it's the instantaneous at this exact moment what's happening. So that's where we're headed, which I showed you because I think it'll make more sense why we're doing what we're doing now. So let's just start working in your packet. That's kind of all the notes I had. I can make up questions, but I think it's just easy to use the ones that they already wrote. And so average rate of change is just the slope between 2 points. They only gave us 2 x values. Those numbers in the brackets are both x values, so what's the first thing I'm going to have to find? The y values. Because where do the y values go in the equation of slope, Josh? How'd you know that? Is it because I spelled rise or y? No, that's the only reason that you know that. So I have -1 comma something. How do I find the something? Plug it into the equation. You got a graph on these, so I mean you can kind of cheat. 1, 2, 3, 4. That's probably going to be -4. Plug in 1. 1, 2. That's probably going to be 4. -4. And they're literally just saying find the slope. I mean, this is like essentially like an algebra worksheet. Just find the slope. And then the next part we're going to find the equation, which is maybe advanced algebra. But it's important to do because it's on the AP test, and it helps you kind of understand where we're headed. So then you're just doing the slope. So -4 minus -4 over 1 minus -1, which is 0 over 2. And if you just draw a line between those, you know, what should the slope of that be? 0, and that's what we got. Does that make sense what I'm doing? Not bad at all, right? Do number 2. I want you to draw it too, now that I think about that. Draw the little line segment that you are finding the slope of. Just so we can start visualizing what's going on. You alright, Don? The hard part of this is probably the fraction breakdown, I guess. So if you plug 1 in for s, you get -1 over 1, so -1. You plug 4 in, you get -1/4. Then I'm just doing rise over run. -1/4 minus -1 is -1/4 plus 1, which is 3/4. Divided by 3. Remember, we don't divide fractions, we invert and multiply, so that's actually 3/4 times 1 over 3. 3's will cancel, and you'll get 1/4. Let me add 1/4. Questions? Alright, flip to... Sorry, I was supposed to wait 7 seconds, I waited like a half a second. Questions? Alright. Let's go to number 11. Secant line is the line, not slope, is the line between 2 points. The tangent line is the line at 1 point. Secant's 2 points, tangent's 1. And I'm going to show you how I recommend you find the equation of the line, because just knowing what's coming next, this, if you just follow, because there's a whole bunch of ways you can find the equation of a line. There's different formulas, different, you can plug in here, a couple different ways. I'm showing you what I think is the best for the future. You don't have to do it the way I'm showing you. You can do it whatever you choose. But what I would recommend is you always start off with this formula, this pattern, this kind of like setup. And then we're going to fill in numbers to find the slope of the line. So this first number, this first blank is always going to be the slope. The second is going to be like your x1 or your first x value. And this will be y1. It doesn't matter which point you use. I don't know if you guys remember that from like math algebra and pre-calc. But you just have to be consistent. So you can use -1 for your x and -1/4 for your y. Or you could use 1 for your x and -1/2 for your y. You cannot mix and match them, right? You can't do like -1 and then -1/2. So find the slope. That's the first job. We got to know what goes in that slope spot. And so it's these 2 points we're actually finding if we do that extended out. That's the line we're finding in the equation. The slope's going to be a tiny negative number. So this is my subtracting the y, subtracting the x's. I got -1/4 on top and 2 on the bottom. And then you know divided fractions, you flip and multiply. So that'd be like -1/4 times 1/2. So I got -1/8 for my slope. Agree? I guess I should agree. You understand what I'm doing? Agree? So -1/8 goes here. And then you're just picking. I don't care which one you pick. Pick whichever one looks easier to you to work with, because you're going to have to put this in y equals form. So you're going to have to distribute. So whichever one looks to you like it's going to be easier to distribute, use that one. I think they're probably both about the same. But I'm going to use the 1, -1/2. And this is one of those, like, it depends if it's free response or multiple choice. In a free response, you can stop right there. You do not have to simplify it. You don't have to put in slope-intercept form. Unless they specifically say to, but they usually don't. But on a multiple choice, they might have that, but they might also have it in y equals form. So you have to know how to kind of manipulate to their answer again. So let's put it in slope-intercept form. So distribute. You know, y equals -1/8 x plus 1, and then you got that plus -1/2. So that would be -1/8 x, and then 1 plus -1/2 is 1/2. I feel like that's wrong.
Why didn't distribute the 1/8?
Oh, yeah. So this is -1/8 x plus 1/8 plus -1/2. So that's 1/8 plus -4/8. So -3/8. That makes more sense. How many had that already before I did? So everyone can tell me.
That made worse.
Questions on that process at all? Try the next one. Try 12. I just wrote all over the page, but I'll get to the sheet when I do it. They gave me the y value, which is nice. Your slope is a third. You want to see like my fraction work here? There it be.
There's one side one.
Oh my goodness. Yeah. What? Alright, so slope is 1/10, and then I used the two common negative 1/2. You can pick whichever one you want, just don't mix and match. So distribute through, so 1/10 x minus, let's say 2/10 plus negative 1/2, but I'm going to write that as negative 5/10. Get myself into the common denominator. And then this will be 1/10 x minus 7/10. How many had that? Questions on it? What if I said put that in standard form? Can you do that? Standard form is ax plus by equals c. Try that. No fractions. X and y on the same side, the number on the other side. Because they'll put their answers like that sometimes too. I'm just trying to practice like moving back and forth to match up with however they write their answer. No fractions, so the first thing you're going to do is multiply everything by 10. And then just get your x and y on the same side and your number on the other side. So here's how it could look on a multiple choice. So you get down to here and you're feeling all good about yourself. I did the slope, I did all I was supposed to do, and their answers don't look like yours. They're like, crap, what do I do now? So see which one of those you would pick. A, B, C, or D. Why are you throwing your hands? You what? Stupid question.
It's like I don't know how to like word it.
Okay. So there's kind of two ways you could get here. You could start with all of these answers and solve them for y, like work backwards to see which one, but that's a pain because if the first one doesn't work, you've wasted your time. You know what I mean? So I would multiply everything by 10 right away. So then I would get 10y equals x minus 7. Fair enough there? Is that easier to match up from that point then? Does that help you get where you go? And then I just want, I'll see which one of these matches. So if I brought that x over, now it would be 10y minus x equals negative 7. So it was C. We had C in the brain. Okay. Let's do another one of those. That didn't go as well as I would like it to, which is fine. So I'm not even going to start with the whole slope and process stuff. Let's just say y equals 2/3 x minus 6. So I'll give you choices for the multiple choice, or for the standard form version of that. are you talking about? That's what? You're pretty messed up. Yeah, that's why you're messed up. So which one of those is it? So I'll triple everything. 3y equals 2x minus 18. Bring the negative 2x, or bring the 2x over. How many Nancy? Good question. Yeah.
If standard form is ax plus by, why would there be y?
Because they might do this. So standard form is the x the first and the y second, but they could potentially put their answers in whatever form. So I kind of use that as a way to just like, let's practice manipulating the equations. Doesn't have to be the x first. Like standard form does, but they don't necessarily follow standard form. Is that fair enough? Alright. That package your homework? There's 10, find the slopes, there's 10, find the equations, and then at the back are the AP questions. There's like 7 AP questions. Those are the ones I want you to really make sure you get to. You don't have the answers to those yet. We'll go over the answers to those tomorrow. But the answers to the rest of them are in there. Tomorrow we'll start taking derivatives. You guys took derivatives some last year, right? Like the basic kind?